Welcome back to the channel, Mariners. Today, we're diving deep into a critical skill for every navigator: contact tracking. Whether you're on the bridge of a super tanker or the helm of a coastal cruiser, knowing what's around you, where it's going, and what it's doing is the absolute key to safe navigation. So, let's get started. What exactly is contact tracking? Simply put, it's the process of observing and monitoring everything around our vessel. This includes other ships, floating objects, and even land masses. To do this, we rely on a suite of powerful electronic tools. The big three are radar, AIS, and ECDIS. Let's break down these systems. First up, radar. It's our all-weather set of eyes, sending out radio waves and listening for the echoes that bounce back. This gives us the range and bearing to a target. When we add ARPA, which stands for Automatic Radar Plotting Aid, our radar gets a major upgrade. ARPA can automatically track multiple targets, calculate their course and speed, and most importantly, warn us of potential collision risks. It's like having a super vigilant lookout who can see in the dark and through fog. Next, we have AIS, the Automatic Identification System. Think of AIS as the social network for ships. Vessels equipped with AIS are constantly broadcasting their identity, position, course, speed, and other vital information to every other AIS-equipped vessel in the vicinity. This takes a lot of the guesswork out of identifying contacts. You're not just seeing a blip on a screen. You know it's the container ship MV Mariner's Dream heading for Rotterdam at 18 knots. Finally, we have our ECDIS, or Electronic Chart Display and Information System. This is our digital chart table. Modern ECDIS integrates information from various sensors, including our GPS, radar, and AIS. It overlays all this real-time data onto our electronic navigational chart. This gives us a complete, unified picture of our navigational situation, our vessel, other traffic, navigational aids, and hazards, all in one place. This is what we call sensor fusion, and it's a game changer for situational awareness. So, how do these systems work together in practice? Imagine you're on watch. You spot a new contact on your radar screen. The first step is to figure out what it is. Is it another large commercial vessel? A small fishing boat? A navigational buoy? Or perhaps a bit of coastline? If it's a large commercial vessel, chances are it's broadcasting on AIS. You'll see its icon pop up on your ECDIS and AIS display. You can immediately click on it to get all its details. Simultaneously, your ARPA will acquire it as a target. This dual tracking with both AIS and ARPA is best practice. It provides redundancy and allows you to cross-check information. If the AIS data and ARPA data don't match, it's a red flag that requires immediate investigation. What if the contact is a smaller vessel, like a fishing boat or a pleasure craft? They might have AIS, especially the more modern ones, but you can't rely on it. Many smaller boats don't carry Class A AIS transponders, or they might have it switched off. This is where your radar and, most importantly, your own AIS are crucial. Your ARPA can track the radar echo, giving you its movement, but you need to maintain a vigilant visual lookout. Small boats can be unpredictable, so giving them a wide berth is always a good strategy. Navigational aids like buoys are another type of contact. These should be clearly marked on your electronic navigational chart, or ENC, which is displayed on your ECDIS. You can see their radar echo and correlate it with the charted position to confirm your own ship's position and ensure the buoy is where it's supposed to be. Your job here is simple: steer to avoid it, leaving it on the correct side as per the buoyage system. And of course, we have land. Your ECDIS will show the coastline very clearly. Your radar will also paint a picture of the land, which can be used for position fixing and to ensure you're maintaining a safe distance from shore and any off-lying dangers. Visual confirmation, especially in clear weather, ties everything together. Now, let's get into the language of contact tracking. There are a few key terms you absolutely must know: CPA and TCPA. CPA stands for closest point of approach. This is the minimum distance that will exist between your vessel and the contact if both of you maintain your current course and speed. Your ARPA and AIS will continuously calculate this for every tracked target. We set a safe CPA limit, and if any target is predicted to breach that limit, an alarm will sound. TCPA is the time to closest point of approach. This tells you how much time you have until you and the contact reach that CPA. A short TCPA, even with a safe CPA, indicates a rapidly developing situation that requires close monitoring. A long TCPA gives you more time to assess and plan. Together, CPA and TCPA are the heart of collision avoidance. A low CPA combined with a low TCPA is a recipe for danger. For example, if a target has a CPA of 0.2 nautical miles and a TCPA of 6 minutes, that's an urgent situation demanding immediate action to increase the CPA. Another important term is MO, which stands for motion vector. On your ARPA or ECDIS display, you'll see lines extending from each target. These are their motion vectors. They visually represent the target's predicted movement over a set period, say the next 6 or 12 minutes. There are two types: relative motion vectors and true motion vectors. True vectors show the target's actual course and speed over the ground. This is great for understanding what the other vessel is actually doing. Relative vectors, on the other hand, show the target's motion relative to your own vessel. This is incredibly powerful because if a relative motion vector points directly at your ship's position on the screen, it means you are on a collision course. The length of the vector will indicate the relative speed of approach. By observing the relative vector, you can instantly see if a risk of collision exists and how a proposed maneuver from your own ship will affect the situation. Changing your course will cause all the relative vectors on your screen to swing, and your goal is to make sure none of them are pointing at you. So let's put it all together in a real-world scenario. You're on the open sea. Your ARPA acquires a new target, 10 miles out, fine on your starboard bow. Your AIS identifies it as the MV Speedy, a container ship. The system calculates a CPA of 0.3 nautical miles and a TCPA of 20 minutes. This CPA is below your preset safety limit of, say, 1 nautical mile. An alarm sounds. What do? First, you assess the situation according to the COL-REGs, the international regulations for preventing collisions at sea. It's a crossing situation, and since the other vessel is on your starboard side, you are the giveaway vessel. You are obligated to take early and substantial action to keep well clear. You could alter your course to starboard, passing astern of the MV Speedy. You can use the trial maneuver function on your ARPA or ECDIS to simulate this. You plug in a proposed course change, say 30 degrees to starboard. The system will instantly recalculate the CPA and TCPA for all targets based on this hypothetical maneuver. You see that this action increases the new CPA to a safe 1.5 nautical miles. Confident in your plan, you execute the maneuver. You bring the ship to the new course and continue to monitor the MV Speedy. You watch as its relative motion vector on your screen swings clear of your vessel's position, and the updated CPA and TCPA values confirm that the risk of collision has been eliminated. Once the vessel is well past and clear, you can return to your original course. That, in a nutshell, is the process of contact tracking and collision avoidance. It's a continuous cycle of detection, identification, assessment, action, and monitoring. It requires a deep understanding of your equipment, a firm grasp of the COL-REGs, and unwavering vigilance. Mastering these tools and techniques is what separates a good navigator from a great one. It's about building a comprehensive mental model of the traffic situation and using technology to enhance and confirm your decisions, never replacing your own professional judgment. Thank you so much for joining me today for this deep dive into contact tracking. I hope you found it useful. If you have any questions, drop them in the comments below. I'll do my best to answer them. Don't forget to hit that like button if you learned something new, and subscribe for more content on seamanship and navigation. Stay safe out there, and I'll see you on the next watch.